Good morning, everyone, and welcome to another live session for Computer Science 20. Today, we are going to be moving into our Python unit, which is going to be the largest unit of study in this course. There are two unit exams, which I'll probably get into a little bit later, but they'll be the first unit exams that you'll do in this course, and both of them have two parts. There's a part that's more like theory and knowledge based, and that's for the first exam, it's all multiple choice. For the second exam, it's part multiple choice, part fill in the blanks, part type in your code kind of deal. And then for both of those two exams, there's also a practical component where you will be given a problem that you need to solve in using Python programming, and then just submitting that file or those files through Blackboard like you normally would with any of your other assignments. So both exams have two parts, and we'll get into a bit more about those exams and do a review a little bit later when we've learned what we need to learn. But it is the largest portion of our class and does represent the majority of the sort of final mark. So make sure that you're doing your best to stay current with the Python materials and keep emailing me every time you have questions. I'm happy to answer them, and usually I get back to you really quickly. So again, don't hesitate to reach out if you're having any difficulties with anything, and I will do my best to help you, whether that be the current material or something that you've been maybe struggling with in Reborg or something before that. One thing I will say about both Reborg and Python, because we're using actual Python code and actual Python files, you'll notice when you take your file down from, or when you download your file from the Reborg website, the file extension is .py. That's a Python file, and that's going to be the same as what we're using moving forward. One problem that we have with that is that there are potential security risks for our network with Python files. Viruses and stuff like that can be hidden inside them. So our email security system strips out all Python files. So you may think you sent me a file for me to look over or help you out with, and it won't come to me. So what I ask is, if for Reborg and for our upcoming Python materials, if you're struggling with something and you need to show me your code so that I can look at it and see maybe where things are going wrong for you, it's best if you just copy your code and paste it into an email to me. So just go right from Reborg, copy, Control C, go to an email, Control V, and then I can take it from there, and I can load it into Reborg and have a look at it for you. If you are going to do something like that, please make sure that you include the library as well, because if you're referring to functions that are in your library, I need that code as well. So you can put that at the, copy paste your main code, and then underneath that, copy paste your library code, and that'll help me out. Try to keep your library clean. I noticed some students have been putting every single function into their library, which isn't a good idea. Remember, we're going to decide what to put in our library based on whether or not we plan on using it again. So if it's basic movement type stuff like turning right or turning around or something like that, where you can use it on different assignments, then that's the stuff that should go in the library. Anything that's really specific to that one step, for instance, if you're trying to find the flag in a maze, that's not going to work for any other program anyway. So don't put it in your library. It just clutters up your library. Just put it at the top of whatever step file that is. So that being said, all the stuff I've seen from Reborg so far looks really good. People are handing them in regularly, and I'm marking them up and giving you feedback if something's wrong. But I'd say 95+% of the time, the files that I've seen from Reborg, the steps that people have been handing in, they all work fine, and you've used the code and the structures that you're supposed to use from the World Info button, and it's great. So keep doing that if you're just finishing up Reborg. And then we move full bore into Python. So you've really been doing Python already. You're just using kind of a stripped down version of a Python editor that has some things built into it to make it a little easy for you to get going. Plus, we've got that very visual output window where you can see how your code affects the robot and what you need to do to get the robot to the right spot and pick up the things that the robot needs and whatnot. So your output has been highly visual, and you've been able to use step-by-step debugging, which is a really important concept and a really important practice in computer science programming. You've been able to use that step through with the little pause/arrow to step through your code, or to use the slider to find out exactly where in your code something's going wrong. And you're going to continue to do that in our full Python unit. It's just going to look a little bit differently. So if you haven't been using that step-by-step or the slider to find out where things are going wrong in Replit, you're going to need to use that process in Python, because the direction we're moving now is going to be away from a visual environment where you can actually see a character moving and doing things, and more into text and data-based analysis. So your output is probably going to be things that you're printed to a screen. And you're going to have to be very careful in managing what you think your code is doing and what you're actually seeing pop up on the screen in terms of words and text and numbers and things like that. So it's still visual, and it still gives you your output, and you can still step through it step by step to find out where things are right and where things are wrong. You're just not going to see cartoony little characters anymore. It's going to be more syntax based, so words and numbers and characters and things like that. So moving into our full Python unit, it's very important that you download an IDE that works for you, and that stands for Integrated Development Environment. And most coders will use it nowadays because it makes your life a little easier. You certainly can type out code just using a plain text file or notebook file or something like that, but it'll cost you time and effort in the long run, because these development environments, or these IDEs, as I'll be referring to them in the future, they have built-in things to help you type in your code, to help you organize your code, to help you test your code out. So without those things, you're really doing a whole bunch of extra work that you don't need to do. So make sure that you use an integrated development environment. And frankly, I don't really care which one you use. Some work better than others for certain operating systems, but I have in the course listed the ones that I think will work best. And there is a web version up there, but it's a little sketchy. So I would strongly recommend that you use an actual program that you download to your computer, and make sure that you're saving your files to your computer in a spot where you know where they're going to be. Organizing your materials and organizing your code and the files that have that code is really important in any programming environment. So if you're used to kind of just saving everything on your desktop, I would get away from that. I would make sure that I create a specific folder called Computer Science 20, and then inside that folder, maybe you've got a rework folder and a Python folder and a Scratch folder, however you want to organize it, but just make sure that you know where you're saving your files in Python, and that you know where you can find them and when you need to hand them in and whatnot, because it is pretty frustrating for you if you do a whole bunch of work on a program and you save it and you're not really keeping track of where things are, and then it's time to hand it in and you can't find it. That's frustrating for you. So if you organize yourself and create a couple folders to make sure that the files that we're going to be saving are in the same place every time, it'll make your life a little easier. So before we start actually coding in Python, let's go through some of these integrated development environments, and I'm going to make a couple recommendations for you to help you kind of set this up ahead of time, so that you don't run into any trouble in the future. I've shared my screen right now, and PiScripter is the one that I use. But now that I think about it, I'm going to go all the way back to the class website, and I'm just going to make sure I get the right class here. I'm just going to show you in Unit 4, Module 4. So right at the top, it's pretty important that you do these assignments in the proper order, because the skills all build upon each other, and you're going to want to learn a skill with a simple program before you try to implement it in a more complex program. And if you downloaded the original assignment list file, it should be in the same order, but in here I just trimmed it down so it's just the Python file. So you'll recognize the format from that big assignment list I gave you at the beginning of the year, and the order that these are in should be the same. So this just shows you what assignment it's part of. So for instance, this first introduction one is part of assignment 11, and it's called basic output.py. And then I just say see Blackboard for complete details, because it'll tell you in Blackboard what you need to do for each of these. But this is just kind of the checklist, and this is the order that you should be doing things in. And you see you got the checklist done or not done. You got the marks for each one of these, and then the number is the assignment that it's part of. So for the first assignment, number 11, there's 1, 2, 3, 4, 5, 6 files that you have to hand in. And that's very similar to the Reborg thing, where maybe you handed in step 1, step 2, step 3, 4, and 5 as one assignment with 5 files in it. So nothing really difficult, nothing really different there. You're going to be handing things in the same sort of format. Some students have chosen to take 5 files and use zip or RAR or something like that, or WinZip, to put it into one zipped up folder and hand in that one zipped up folder, and that's fine. And some other people have decided just to attach all 5 assignments to your hand in, just submit 5 assignments as 5 different files. You still only submit it once. You go in and you select all 5 files and then make sure they're all attached to the assignment, and then you hit the submit at the very bottom. And some people have chosen to take that route. That route's perfectly fine. It doesn't make any difference to me. Just whatever you do that makes the most sense to you with regard to storing those files and handing them in. It's fine as long as I'm getting them and I'm able to see them and mark them all as well. So with regard to your Python programming, and this is a carryover from Reborg, some of you have probably gotten some feedback and maybe a couple marks off because you haven't been including inline comments using the hashtag, or there's other methods with 2 quotes or 3 quotes or whatnot. But some of you have not been commenting things in Reborg, and that's something that needs to be done because there's an expectation after step 4 where we show you how to do inline comments, that you're going to continue that in the future. And they don't need to be detailed. Again, in one of our live sessions, I went through, this is enough commenting, this is too much commenting and whatnot. But you should be commenting the major structures. If you've got a function that does something, you should have a little line in there saying what that function's supposed to do. Or if you've got a big loop in your program that sort of controls a bunch of stuff in your program, you should have a little line above that just indicating this is a loop that takes in a username and a user password and then does something else. And it doesn't have to be a paragraph long, just plain English, enough to indicate to a person what that structure is supposed to be. Remember, you can assume that the people reading your inline comments have a basic understanding of programming. You don't have to explain to them what a print statement does and what a move does and things like that. So just keep that in mind moving forward, because you'll continue to get that feedback and some marks off that you need to include internal commenting. So just save yourself the trouble. Make sure you put it in there the first time, and then all is well. Okay, so that's the order of completion that I think might be helpful for you right at the top. And then right below that, you see it says downloaded Python, Thonny, PiScripter, PyCharm, and Replit. So this is that area where I give you some options of IDEs, development environments to use with this, whether you're working with a Windows machine, a Mac machine, or a Chromebook machine. So for the Windows, you can use Thonny, PiScripter, and there is a web-based version called I call it Replit, but it's repl.it, where you sign up for an account and then you can do Python programming online. You can store your code online and download it and hand it in when you want to. So if you like working in a strictly web-based environment without having to download and install something on your computer, you can do that, but there's definitely some shortcomings to using this online system. And there are others that are strictly web-based and online, but they all kind of have the same shortcomings. So I strongly recommend using one of these ones listed up here in the Windows, Mac, and Chromebook versions. So there's your options there. And I've never had a student who hasn't been able to use one of those. So, for whatever reason, things are not working out, and you're having trouble opening it or coding in it, or getting error messages or anything, just take a screen cap and send it to me, and I'll help you troubleshoot that. I'm gonna make a note right away, right before we start looking at any of these, and that is that you need to have Python, the programming language, installed on your computer. It's kind of 2 separate things. You have the base core functionality of Python installed on your machine, which is a pretty easy process. And then you've got another file and program called PiScripter or Thonny, the ones that we're talking about, that you can use to code. And they kind of interact with each other, but it's not just one program that you have to install. You got to install the programming language, and then you got to install the actual integrated development environment, PiScripter, Thonny, something like that. Sometimes Python is already installed on your computer and you don't need to worry about it. Other times you have to go to the Python website, download the Python file. Basically just installs Python on your computer. And it's a very simple download and a very simple install. It's kind of like a download the program and then open it, and then it might give you a message saying this is going to install Python on your computer, and you just click OK, and it does what it's supposed to do. If that is not working for whatever reason, or you don't have, maybe you're working at a computer where you don't have administrative access to install programs, we have some workarounds for that as well. But maybe that's one of those things that you should just email me and we'll try to solve it. But solve it right away. And so if you're having trouble, you can't really do anything until you get it installed or get all your programs, your IDEs working and whatnot. So don't leave it. If there's a problem, let's identify it right away. So these are the options. They're not the only options, but they're the ones that we've used in this class in the past, and they've worked the best. And the first of these, well, it's Thani here, but the first one that I always recommend is something called PiScripter. And you just Google PiScripter to find it. There's a link on the class website in that area I just showed you and whatnot. The icon, you'll know you'll find it because the icon is a little Python with a pencil in there. So you just Google it, and you can go to PiScripter, and then you can download it and install it. So after you download it, it'll just go down, and it'll end up in your little tray down here in your downloads folder, depending on what browser you're using. See how it's downloading right there. I don't need to download it because I've already got it. So I'll just pause and cancel that one. But it's basically the same process you would use to install any program. After this is done downloading, you double click on it. It opens up a window saying this is going to install PiScripter, and you just kind of click through and it'll do its thing. But if you're using PiScripter in this manner, you do need to install Python or make sure Python's installed on your computer before you do that. And the place, this is all, you don't have to memorize this because this is all in those notes on the website, on our class website. But if you go to python.org, it's kind of like the official Python website. Now, Python was something that was developed and is shared. And it's like shareware, freeware. You don't need a license to use it. It's all developed and maintained by a group of programmers. It's part of the sort of open source code revolution where many programmers work together, and then there's a smaller group that says, we'll make this update, we won't make this update. It's very stable. It's been around for quite a long time, and it's very popular software. So it's very stable. You don't have to worry about it. You don't have to worry about it, being a security risk or threatening your computer in any way, shape, or form. So at python.org, there is a download section, and all releases, source code, Windows. Don't do the source code. That's for people who want to like program on top of Python and make it better and submit things to actually improve the programming language. But likely you've got a Windows machine or a Mac machine. Other platforms would handle Linux and Chromebook and things like that. But I think most people would either have Windows or Mac. So you would go to Windows, and then at the top it says there's 2 Python releases for Windows. There's the latest version, and then there's a different version underneath. Now here's a really important thing in this class. There's some code, some ways you do things, and some specific code that used to work under an old version of Python, and then they basically did a huge update, I don't know, 10 years ago, maybe more, where they made like an entirely new version of Python and made a whole bunch of changes and made it a lot better. Now the old code still works, but the way that you words you type in and syntax and whatnot, there are several differences between the old version and the new version. So the old version is just referred to as Python 2. Okay, so Python 2 is the old version. We don't want that. We want Python 3. So make sure that you're installing something that says Python 3. Now, this is not the only place you can go to get the files to download and install in Windows. It's the one I would recommend. But as far as installing the actual Python programming language on your computer, I'd recommend going to this website. And if you've got a Windows machine, you click on Python 3 release. It's stable. It's been tested. It's all working fine. And the exact same thing as before. You click on this, it's going to go down into your, browser download or into your downloads folder. It's going to be a file. You just double click on it, and then it's going to say this will install Python on your computer. Click, and it's installed. So you will have to do that. And again, sometimes Python's already been installed on your machine for some other process that's happened on your home computer in the past. And if that is the case, it'll probably pop up a message saying you've already got Python installed on your machine, or give you the option to update it or something like that. So it doesn't matter if you've got Windows or Mac or some other program. The process is the same. Make sure you're downloading and installing Python 3, not Python 2. That's the first thing you should do before you download and install any of the IDEs. You should make sure that Python is installed in your machine. After you're sure that Python has been installed in your machine, you got the success messages or whatever, that's when you would go to PiScripter and then download and install PiScripter. So it's just basically two separate programs. One is always on your machine in the background. It knows how to run code, Python code. It knows how to interpret it. It knows how to do all the background stuff. And then the IDE, like PiScripter, is the thing that you're going to be working in. You're going to be typing your code in. You're going to be testing your files in. And it just communicates back and forth with the program that, with the Python language that's been installed on your machine that you never need to see. It just runs in the background. And they just communicate back and forth, and you get to see what you need to see. So that's PiScripter. That's the one I use. When you open it up, looks like this. Yours might look a little differently. I've got mine set up so that it's got black background and white writing. It's easier on the eyes. Having a white, especially if you're in front of a computer for a long time every day, having the white constantly bombard your eyes can be a little bit tough on the eyes. So there's an option in here to turn on inverse color coding or something like that. I can help you with it if you can't find it. It's somewhere in view, I assume, possibly set up. Just quick check here for you. I can't remember where I went to do that. Layouts. Might be in styles. Yeah, there. So like Windows Dark or one of those ones. It'll change your background color, make it easier in the eyes. I don't care. It's up to you. You don't need that. It's not going to change anything about your code. It's just the way that you look at it. When you open a new file, you're probably going to see something like this, where it's got some documentation at the top. It's basically just where you can put your name and copyright and things like that. And then it's got a built-in function called main, which you could use, but I never do. So I usually just Control A and, to select all and delete it. Just start straight up with a blank document. So this is what PiScripter looks like on the inside. It's got a little file menu, so you can find files that you've been working on. You can have multiple files open at once. So there's a file that I was working on. Here's the one I just opened. You can have as many tabs as you want open at once. So that's reasonably handy. And then there's a bunch of different tools that we're going to look at along the way that can help you test your code and make it, go line by line, so you can do step-by-step debugging to find out where any issues are in your code, and look at things when we're using variables and certain types of data where you can see those, and you can move windows around and change the size. This is basically your input window where you are doing your code, and then down here is where you're going to see the result of your code. So for instance, if I just type in, I'll just get rid of what I was working on here, Control A, delete. If I type in the most simple of Python codes, print, and then hello students, and then I run it by hitting this. You can either hit Control and F9, or you can just hit the little run arrow. Your code runs, and then the result is down here. So you see how it says hello students down there. Does that because I told it to print. So print basically says print to this screen down here, which is called an interpreter window. And it's just going to be where all the results of your code are going to go. If I type print brackets 5 plus 4, it's not going to print 5 plus 4. It's going to print the result of 5 plus 4, because computers love doing math. It's going to print 9. It still printed hello students because that's still part of my code. But you notice when I said print 5 plus 4, it just printed the number 9. And it'll do that with anything, multiplication, division, exponentiation, that sort of thing. That's what PiScripter looks like on the inside, and that's the option I use. And if you want to sort of match up what you're seeing with what I'm showing you in tutorials and videos and things like that, I'd recommend using PiScripter. There is another version of a Python program that you can use that I don't believe requires you to download the entire Python programming language from python.org. It's an option. It works in a very similar manner to PiScripter. But the benefit of it is that it's got kind of like Python built into it already, so you don't need to install it in the background. But again, there's some things about Thonny that I don't like as much as the things that are in PiScripter. That's why I don't use it. But it's certainly an option. You'll be able to do all the assignments. You'll be able to do everything that we can do more or less in PiScripter. It looks a little different. The process is a little different sometimes. But still, every semester I have students use Thonny. So that's Thonny. If you Google it, first thing pops up, thonny.org. Python IDE, remember Integrated Development Environment for Beginners, and it's got the big TH as the sign for it. So this is very similar. You go to the Thonny webpage, and then you can download it for Windows, Mac, or Linux. I'm not sure if the Linux one is working. I don't know if I have any students using Linux anyway. Very similar. You download it, you install it, and it just kind of works. And if I open up my Thonny, so I've got PiScripter and Thonny and other languages and IDEs on my computer, so I kind of got everything on here. So this is what the Thonny program looks like. You'll notice it's a little different, but it's still very similar. You've got the programming or coding area up here. You've got your interpreter down there. You'll notice there's fewer tools, and some students prefer that so that they just don't have as many options. What we're doing in Python doesn't require a whole lot of extended libraries or extended tools or things like that. So this is a slightly simpler than PiScripter, and some students like working with it, and some prefer to use the exact same thing that I'm working on. Again, I don't care. It works the same way, right? Print, hello students, print 5 times 4, and then when I run it, oh, it makes you save the file first, then that kind of makes sense. So maybe I'll just call it test.py or something like that. Now it runs the code and it says hello students. It says 20, exact same thing as what you saw in PiScripter. It just the environment looks a little different. The windows are in slightly different places. It has slightly different tools, but it's got everything that you need to complete this course. And I believe, at least it used to be, that you could install Thonny and not have to do the Python install in the background from python.org. I think this one runs as standalone, so it doesn't actually interact with your computer. This is just kind of like a learning program, and it's all encapsulated in one program. So that might be an option that you might want to use if you're having trouble installing Python on your computer or something like that. Certainly up to you. You can do all the things you need to do in this class with Thonny or with PiScripter. Okay, then another option I said was Replit, so it's repl.it. And this is the one that's completely web-based, and it's worked well for some students, but let's just say occasionally it goes down, or certain tools break or whatnot. It's definitely not as stable as those other two that I mentioned. I have an account in Replit, and I use it occasionally, but it's not my go-to. So if I go to log in, you'll have to sign up, but if I go to log in and then I continue into my account, yada, yada, yada. I remember last school year, they had some significant problems with your ability to debug and test your code. And that did cause some issues for students for sure, which is why I'm kind of trying to steer students away from it a little bit. I'm just going to turn off my sharing right now because I don't want anyone to see my email window, and just make sure I update that. Obviously, they've made some changes. And they've been trying to move to a subscription model where they get you to pay for it instead of it being easily usable for free. Don't pay for anything in this class. There are always free versions. So if you are trying to use Replit and it's trying to get you to pay or start a membership or something like that, don't. Okay. You can still use it for free. But I mean, the short message is don't pay for anything in this class. You don't need to. I'm going to start sharing again. I had to verify my account because I haven't used it in a while, and then you'll see in a second. Should be popping up. This is what it looks like on the inside. It's all web-based, and then you can make a new Replit. And when you make a new Replit, there's a bunch of different programming languages available in here. You see there's Python and Java and Node and C. So this works for a whole lot of different languages. Obviously, we're using Python, so you can just click on the Python, and then you can name your program. Just call it test12, and create a Replit. And then what you're going to see is somewhat similar to what we saw on the offline editors. And you know, this window over here, this black window is where you're going to see your output, and over here is the window where you're going to be writing your code. So print hello world, print 5 times 4, and then there's a run button up here. And you'll notice that your output is exactly the same as it was before. There are tools built into this. This is the one that's very important that wasn't working very well last school year, and they may have fixed it, but they may have not. And the debugger is a way for you to step through your code and run line by line to test it. So you can run it and it'll test your entire program, or you can set it up so that it's got things called breakpoints, where it'll stop on each line as you're debugging it. So you can run it to here, which is just the first line, and then you can run it to there, which is the second line, and then ideally you can see what's happening at each line of your code. Again, I don't think it works as well as any of the other options in this class, but if you really are against installing something on your machine and you want to do it online, Replit is an option. Because it will save your program and it will give you the opportunity to go up here to files. It'll give you the opportunity to download. So this one's just called main right now. My project is called test12, but this program is just called main. If you're using Replit, please rename these Python files. So if this was a program called test12, make sure that you would do something like that. Otherwise, you just hand in a whole bunch of files called main.py, and it becomes a little bit more difficult for me to discern which assignment or which step or whatever it is you're working on. So rename those before you hand them in, and then you just download them, just like you would download a reborn file, or you would save a file on your computer and hand it in. So it is an option for people who want to use a web-based environment, but I can't guarantee that all of these tools will be working all of the time, because in the past some of them have broken. But it's definitely, it's definitely an option. And there are other online web-based versions of Python too. This is just kind of been the most popular one over the years. So that's 3 good options on software that you can use in this course in order to complete all of the assignments. And I just want to check and see if there's anything else that I might have recommended in there. I've got Thonny, PiScripter, PyCharm. I think there is a good version of PiScripter for Mac now, but there didn't used to be. So if you're having any trouble at all installing Thonny or PiScripter for your for a Mac computer, there's also one called PyCharm, which is a bit of a bigger download. It's a big program that has a lot of options that we're not going to use, but it does work very similarly to the other options I gave you. It's just there's going to be more stuff built into it for experts who want to do expert type things. But I've had students regularly use PyCharm without any issues. So that's an option for Mac only, I believe. And Chromebook was where things were a bit more difficult last year. So if you've got a Chromebook, there's something called Geany, which is the one I recommend. It's very simple. It's very straightforward. It'll look somewhat similar to what you're going to see in the videos with PiScripter or Thonny. And then there's one called VS Code as well. It's Visual Studios. It's a little bit, it looks a little different. It's kind of like PyCharm. It's got some pro stuff built into it. So it won't look quite as simple, but all the simple tools are still there and the layouts are still there. So that you can use that as well, or you could use a web-based version. I'd say like 95% of my students over the years have either had a Windows machine or a Mac machine and have had no problem with either Thonny or PiScripter. Okay. This notice about Replit accounts is basically just kind of a workaround if that debugger tool isn't working properly. And it looked like it was when I just checked it. It looked like it was fixed. But there are other places where you can test your code using step-by-step debugging if for whatever reason that tool goes down. So if you are planning on doing all of this completely 100% online without downloading and installing something on your computer, you can use either of these two links to step-by-step debug through your code if you've got a problem too. So that was just something I put in there as a workaround when that debugging in Replit wasn't working very properly. This is, I'm just going to hide this for now. This was a questions and answers post that was a little bit, yeah, that's actually probably from a little bit later in this unit, and we'll have our own question and answer things, so I'll just hide that from you. You don't need to see that. Make unavailable. All right, now we have a textbook for the Python unit. We are not using it. You do not need to use it. What it is it is a very comprehensive reference for you if you are having trouble with a specific function or formula or formatting kind of deal, and you want to troubleshoot it. I think most of us probably just go to the web now and look in some of the forums that have, essentially everybody's asked every question ever, so there's going to be an answer there somewhere. But this is also a really good free PDF textbook that was created by a computer programmer, but also an educator. So they sort of understand how to start with nothing and build people up. This is where I started when I wanted to learn Python for the first time a long, long time ago. It's called How to Think Like a Computer Science. It's long, it's like 400 pages, but it goes through things in a lot of detail, and it assumes that you start with nothing as you're learning Python. So if you want to go maybe a little bit deeper into Python than we go to in this class, it's just an excellent textbook. It's totally free. Download it, and it goes through everything from things we've done already, how to build an algorithm, how to build a flow chart, data types. All the stuff that we are going to learn in Python are included somewhere in this book, not necessarily in the same order. And we're not officially using it, but it's a good resource if you're having trouble with something very specific, a variable name. Why is my variable name not working? We will go through that. But if for whatever reason you forgot or you couldn't find out why this one stupid variable name is crashing my program, you could just go to this textbook and use the search feature and, oh, okay, I started that variable name with a number instead of a letter, and that's why it's not working. So it can be very good for helping you troubleshoot something specific that's not working. It's very well laid out, and it also has a lot of things that we're not doing in this class because we just don't have the kind of time that would be required to become an expert in Python. But it is there as a resource, and that's what it should be used for. I do not expect anybody to start at page 1 and then read through 100 pages of chapter 2 and 3 for tomorrow kind of deal. You have everything that you need in the tutorial sessions, in the tutorial videos, in the assignment descriptions, et cetera, et cetera, et cetera. It's not necessary, but it's there if you want it. And then we're right into 4.1, which is an introduction to the Python language. I've got about 20 minutes in our hour left. I know that for the first day in Python, people are probably mostly just going to be downloading the programming language, installing it, downloading the IDE, PiScripter, Pythonide, whatever you want to use, installing it, making sure it works. So I don't know that I want to go a whole lot further than this, but what I'm going to do is I'm going to just go through the first little bit of Python, and it's not really a whole lot about specific code and syntax you have to type in, but it just gives you a bit of an overview on what Python is and why we're using it. So I'm going to just go into 4.1. You'll notice there's a video, and the video is essentially me going over this slideshow and adding in little details or doing little showing you. It shows you on the slide what you need to do, and the video will show me actually doing it and showing you why it works and what you should see on your output screen. So it's kind of like a tutorial based on this slideshow. And I don't want to duplicate all of that effort in all of these live sessions. So I want to try to use the live sessions for troubleshooting things that might be that I'm noticing from assignments that might be being done incorrectly, or addressing things that students have emailed to me saying, I tried this, it didn't work, why is it didn't work? Whenever students ask questions, they're usually not the only people that are having trouble with a concept or having trouble with the program. which means that when students ask me questions, which is why I love it when students ask questions and send emails and whatnot, I can use those live sessions to bring it forward saying, hey, I had a student ask me this question about why this isn't working or how to make this work. And then I can use these live sessions to not repeat the stuff that's already there, but to say, okay, now if you're running into this issue, this is how you fix it. If you're trying to start this program, this is a good idea how to get going. I don't see much point in me just going through the video that to completely recreating the video in a live session, going through the slides. So I'd like to keep these live sessions more for elaboration, things that aren't in the slides, things that aren't in the videos, things that might help you. So just keep that in mind as we move forward. It is important that if you're struggling with something that you reach out to me, or if something's not working properly, email me, because it might be something that's affecting or of interest to more students than just yourself. So working together and us communicating effectively will benefit everybody, not just you. So Unit 1, just a brief background of Python, and it was created in the early 90s, which actually makes it kind of a late syntax-based programming language. A lot of them have been around since the 60s, 70s, 80s. It's relatively new. It was designed to be super simple and easy for programmers to learn how to, or for students to learn how to program. A lot of the earlier languages included so much syntax to do simple tasks that it could be overwhelming for students. For instance, if we're using the Java programming language and I wanted to do what I'd done before in PiScripter, where I just typed hello students and then 5 times 4, you'd need a block of code about this big to run that, whereas in Python it was 2 lines. So it was designed to do as many of the big, more complex processes that you could do with any language, but to do it in a simpler form and with less code to make it easier for students to start. So it's a great programming language. If you decide to go into post-secondary, if you go into any sort of SAS Polytech training or university or college or something like that, and you're learning computer programming, usually the professors will choose Python as the very first language that you learn, which is, I think, a major benefit to you, because if you are planning on going into post-secondary and going into coding, you'll probably have a really good head start on how to use Python effectively. And frankly, from what I've seen in some of the course descriptions and whatnot, you may be able to, you may have like 70, 80% of the stuff you need and the skills and knowledge you need right off the bat, which would make taking that intro class a lot easier. Not every college does it the same, not every university or tech school does it the same, but if they do use Python and you do well in this section, you'll have a real leg up on some of the people that maybe have no Python experience moving into those classes. So it was made by a man named Guido van Rossum, who now works at Dropbox, which is an online web storage program. And Guido is actually the impetus, or is actually the inspiration for Reborg, although it's kind of indirect. A computer programmer, a professor at a university, wanted to create something that looks like Reborg. This is well before any of this stuff existed. And he created a computer called Guido van Robot. And it looked very similar to Reborg, and it was a U program on one side, and then you see what Guido the robot does, and he goes and he he opens doors, and he does very similar stuff to what Reborg Reborg looks like. And so it was named after Guido van Rossum. And then over the years, people have taken that original GVR the robot, or Guido the robot program, and made different versions. One of which is Reborg, which was created by, I can't remember his name, but anyway, I found Reborg to be the one that's the best in making a transition from a 50-50 kind of cartoony visual environment and syntax into full syntax, which is what we're going to be using from this point forward. When I say syntax is just the way that a language is written and interpreted. So it doesn't matter if it's computer science or if it's your English class. Syntax is important. It includes things like capitalize, when to use punctuation, that sort of thing. Basically the rules of a written language. And unlike when you're doing, when you're writing something for your English class, if you misspell something or if you put a period where it doesn't belong, the teacher can still read your paper and can still understand what you want to do. We already know from our experience so far that it doesn't work the same way with computer programming. A computer will only do exactly what you tell it to do. It has no means of being subjective and saying, oh, I think they meant to do that and whatnot. At least the stuff that we're using. which means you have to have everything perfect for it to work, which means if something's capitalized and it doesn't, a word is capitalized and it shouldn't be, or if you include a single quote instead of a double quote, or if you include the wrong type of bracket, those little things will break your program instantly, and you have to track down those syntax errors in order to make your program run. So you do have to have a mind and an eye for detail, and you have to be very careful about what you're typing in and how you're typing it in, because little things like that will just cause your program to break, and then you got to go through the hassle of finding out where did I miss a period, where did I miss a colon, kind of thing. So that's just the way programming it is, and it is that way in every language, so it doesn't matter which one you use. If I refer to a script, it's basically just a small program meant for one-time use. We will be saving them, but they're not going to be huge libraries of files that we're using to solve some, big business problem at Amazon or whatnot. I mean, most of the time when you use Python in larger scale enterprises, they're going to be very complex programs with lots of folders and libraries and files and classes and things. We're learning it, so we're just going to work with kind of simple one-off programs that solve a specific problem, and that's all they need to do. You've got lots of time to gain experience with much larger scale programming projects as you move forward if you want to. But this class, we're going to try and keep it relatively simple and straightforward. Here's a little problem you need to solve involving words or numbers or something, and then you need to program it, and it needs to show or output the answer. And so that's how we're going to approach it. That doesn't mean that it's easy. It's just simplified. The code that you need to produce those answers is going to be is going to test your critical thinking skills, just like Reborg is testing your critical thinking skills. You have the skills, you know the code, you know how to, you know how function works, you know how data works, you know how variables work, and you know how to get input in. You know all those skills, but the important thing is, can you use those skills to solve the logic problem? How am I going to take these skills I have and then solve the problem and get the answer? And that's where the critical thinking comes, and that's where the application of what you know as far as the skills comes into play. You're going to find that you learn the skills very quickly, because they're not particularly complex as far as understanding what a loop does and understanding how to make a variable and understanding how to use an if statement. You already have a lot of that in your tool bag already. That's not the hard part. The hard part is not learning how to use each tool in each line of code. The harder part is taking that knowledge and making it work for a specific situation. And that's where your challenge is going to be. All right, Python's used a lot of different places by a lot of big companies, by a lot of big universities and intellectual property holders all over the world. But most big organizations don't just stick to one programming language. They'll be using multiple programming languages. They'll use one programming language for one part of a project, and they'll use a different programming language for another part of a project. And that comes with experience, just the ability to pick which programming language is going to work best for me and the customer, or whatever the application is. And for most big companies, it means that you're going to have to learn multiple languages, because nobody just uses one. But it is used with all the big ones. I've got Yahoo on there. Yahoo's not really that big anymore, but Google and YouTube is owned by Google, and all sorts of different huge companies and online game providers and things like that. They use Python along with other things. So it started out as being something that is used for small to medium-sized projects, which is what we're using it for. But nowadays, you can do huge, large-scale pro projects, and people do. Okay, so there's a little terminology here: interpreted versus compiled. Compiled, if you're using a programming language that requires a compiler, Java would be the one that I would point to most specifically. It's actually a bit more complex for your computer. You have to have, you make your code, and then it has to take all your code and build it into a program module, and then there's something behind the scenes that allows you to open that and run the things that are in it. So it takes a little bit more computer resource for compiled languages. Whereas Python is what's known as an interpreted language, and it's very straightforward. It's basically, there's an interpreter built right into your machine. That's the Python thing you install in the background, and it doesn't need to compile all these files and folders into one bigger file that you have to that you have to unzip or unload or whatever. It's basically you have a Python file, it runs through it line by line, it does what it needs to do, and you get the results very, very quickly using very few computer resources. So that's one of the reasons that I've chosen Python for this introductory class. It's very straightforward. You type a line of code, it can execute that code instantly without having to do a whole bunch of stuff in the background, and you see the output. Now, that doesn't mean that it's less powerful than Java. It just means it's different in the way that you code and then it actually runs on a person's machine. So the interpreter, I'm just going to refer to these as IDEs, integrated development environment. We use it. We use Thonny, we use PiScripter, whatnot, because it's got some built-in stuff that just makes coding easier. It helps highlight where potential errors might be. There's something called code completion, where if you start typing the first couple of letters of a function, it'll kind of try to autofill it in for you so that you can do less typing and things like that. It puts it color codes certain variable types, and it color codes certain functions just to make it a little easier to read, so not everything is typed in black or typed in white. It helps you see the structure of the program and leads to fewer errors and less typing, easier to test. That's why I recommend using an IDE, and most professionals would use an IDE. Debugging your code is very important. That's what I was saying when you go through your code line by line and it executes the code line by line. We've learned in Reborg. That's going to be very important too. The way that your debugger, your step-by-step debugger works is going to be different depending on whether you're using Thonny or using PiScripter. But what you want to make sure that is happening is that it's actually making you hit enter or F5 or F7 every time it runs a line of code. If you try to run the debugger and it debugs the whole program at once, that's not what we want, because that is an option as well. We want you to be able to go through it line by line to make sure that each thing is happening in the order that it should happen, and then the results that you're getting are matching what you think you should be getting. So make sure you understand how to do step-by-step debugging. That's part of the first assignment, that you basically take a screen cap of your window when you're in the debugging mode so that I can see that you've got the line by line. It's also, you can also just make a little video. Screen capture software like Screencast-O-Matic. I'm going to say that again, Screencast-O-Matic. It's free. You can record what's going on your screen. You can easily send me that video and I can say, oh, okay, I can see what's going on here. Oh, this is what you're doing wrong. You're hitting F5 instead of F7 or something like that. So if you ever want to attach a video showing that you understand how to do something, or when you're troubleshooting an error, that's acceptable too. Okay, I don't want to go too much further here, but I already showed you this. The way that you can get Python to print something for you, and by printing it basically just means outputting it for the user, is the word print with lowercase letters. Then you need a round bracket. Then you need quotes. Then you type what you want to show up, and then quotes, and then end bracket. So it's built on that container idea. Anything inside a container is what's going to be executed. If you forget to leave, if you forget the end bracket, it doesn't know that your container is closed. If you forget the end quote mark, it doesn't know that you're done what you want to print. So again, you have to be very specific. Computers only follow the instructions you give them. So you've got to get used to making sure that your syntax is right. Otherwise, you're going to spend a lot of time trying to track down where you forgot that bracket. And it's going to happen. It's going to happen often, and you'll just get better at it as you do it. But oftentimes you'll spend 5-10 minutes trying to troubleshoot something, and you finally find it, and you missed a bracket somewhere, and you go, like I spent a whole lot of time, and that was a simple error, and that was a silly error, and it just cost me time and effort. And yeah, it can be a bit frustrating, but don't let it frustrate you more than it should, because it happens to everyone, and especially me. I will forget something simple. This is just an important message about using Python 3 instead of Python 2. Okay, so there are differences between Python 2 and 3. We've gotten to the point that I haven't had too many problems with students accidentally submitting Python 2 code, but there are some differences. For instance, in print statements in the old version, you didn't need the brackets. But for print statements for the new version, you do need the brackets. So I want everybody working on the new system, 3.0. And if you think you might have it wrong, let me know so I can help you out. Okay, now the first PowerPoint, again, today I'm kind of going through that through the PowerPoint like I did in the video. So I am replicating some effort here, and I don't really want to do that. I recommend you just watch the video and chip through this, and then understand white space, which we've already talked about in Reborg. It's exactly the same in Python. And then this is really the first little program you have to build. It's just you need to have a bunch of print lines, and you need to have the quotes proper and the brackets proper, and you've got to have things in the correct order, and then you'll be able to make an egg and a saucer and a stop sign and a hat. And yes, they look terrible because they're just little ASCII art, but the point is, do you know how to use print statements in Python? So that's where you start. Okay, 3 minutes left. All my time has been used, and we'll pick it up on Wednesday or Thursday? Wednesday? Yeah, Thursday. Whenever our next session is, I think it's Thursday afternoon. We'll move into 4.2, and we'll actually start talking about data and variables and some of the things that we didn't learn in rework. So thanks for everything, and keep those questions coming. Have a nice day.